I'm Andy Byers, Director of Strategic Partnerships at Ansys. We are very excited to be participating in Microsoft Build 2023. And as longtime partners with Microsoft, we have a lot to talk about. In this video, we are first going to introduce to you our new open source Python project called PyAnsys. After this, we are going to show you a new integration we have built between one of our popular products, Ansys Discovery, and Office 365. For those of you who aren't familiar with Ansys, we create engineering simulation software for industries around the globe to help engineers design and virtually test their products on a computer before they ever build them in real life. Let's take a quick look at a short video about Ansys, and then you will hear from my colleague, Olivier Ricordel, who will introduce you to these new developer tools and API packages available on GitHub. Enjoy, and thank you for joining us.
How boldly would you dream if you knew what the outcome would be? What boundaries would you push? What limits would you surpass? If the unknown no longer held you back, imagine how far you would go. Knowing is power, and it's possible with Ansys. We simulate the world as it really works, allowing you to see into the future and create it, revealing one truth after another, determining with certainty what works, what doesn't, and what's next. From the oceans to outer space, from human ingenuity to AI, from the life-saving to the world-changing. Ansys sets the future in motion with confidence. Be daring, be bold, and take a leap of certainty.
Thank you, Andy. I'm Olivier Ricordel, Developer Partner Program Director at Ansys, and I'm really excited to share with you our new developer tools and API. At Ansys, we build simulation software based on physics. Our customers use our products to better understand how a new design responds to conditions in the real world, such as thermodynamics, fluid dynamics, or mechanical energy. In this video, you saw a few examples of Ansys simulation products helping our customers in automotive, aerospace, healthcare, high-tech, and sustainability that help them develop and test their new design with simulation. This approach reduces the need for physical prototypes, save cost, and reduce time to market significantly. When you think about the development of a new electric vehicle, there are many new challenges with the battery, motors, autonomous capabilities, with LiDAR or camera sensors, electronics, and more. For each component, Ansys' suite of products can simulate multiple physics to take a leap of certainty. If you're not familiar with Ansys, the company was founded 50 years ago and has now more than 6,000 full-time employees in more than 90 offices worldwide. Simulation is all we do, working closely with Microsoft, our partners, and more than 3,000 universities. I mentioned physics a few times, and that's how our product portfolio is organized, with the addition of systems, safety, and digital mission engineering. To amplify our product portfolio, we have our simulation platform that adds exponential value, and especially our developer tools. Finally, we work closely with our communities of universities, industry leaders, startup partners, and we are eager to grow our developer community with our new project, PyAnsys. So what is PyAnsys? It's a collection of application programming interface, or API, to give access to our simulation products using Python. Code can launch our products, import data, run simulation, and use the results with open data libraries, or even create totally new user interface for web and mobile, bypassing the desktop. This enables our customer to automate their workflow and run more simulation, connect multiple physics, and let our developer community expand our simulation capabilities with new libraries and new solutions. All our APIs are open source and available on GitHub. As we dive into our vast product portfolio, you can see the Python logo where we provide this new API. PyAnsys is a vibrant project, and we release new API and updates on GitHub daily. We look forward to working with our developer community to report issues, propose changes, or simplify the API. In the last few months, we witnessed a tremendous interest for AI. With the progress of natural language models such as GPT, AI will transform every industry, including simulation. With PyAnsys giving access to our products' capabilities with Python, developers can use any AI framework, such as PyTorch, to design new prototypes and analyze the results of their simulation with AI. Developers can also work with Azure GPT or GitHub Copilot to write code faster, optimize it, or analyze it. So it is time to launch Visual Studio and look at some PyAnsys code with Sandeep.
Hello everyone, my name is Sandeep Medikonda, and today I'll demonstrate some key applications in which GitHub Copilot and Microsoft Visual Studio Code have been a game changer for PyAnsys workflows. Now, while there are several application areas using PyAnsys, such as coupling with machine learning problems, multi-physics, workflow automations, etc., in today's demo, we will focus on web applications built on top of PyAnsys using GitHub Copilot. In particular, I will focus on 5 use cases where we start with some basic autocomplete features of Python classes and methods. We will then look at generating docstrings or unit test functions. We will also look at creating or manipulating code based on existing code structure in the projects. And lastly, we'll look at creating post-processing results as well as creating advanced GUI components inside web apps with the code completion feature. Let's move to the demos. In these demo examples, I'll be making use of and referring to Ansys Fluent, which is our computational fluid dynamics solver, as well as Ansys MAPDL, which is our structural and thermal solver. Okay, let's start by looking at our first use case where we generate a Python class. All we need would be a simple prompt where GitHub Copilot auto generates the code for us. We could also enter the advanced code completion and select anything that is generated by GitHub Copilot from there, which matches our current needs. GitHub Copilot is also great at generating docstrings for existing classes or methods, and that has been demonstrated here. It works equally well for the methods inside each class as well. Next, let's look at generating or manipulating code based on some existing code snippets. First, we could start off with a prompt which simply generates some code, and we could give that as context for another class we are developing which launches Fluent and checks the mesh. Again, entering code completion gives us a lot more options which we could then accept or reject. You could also write classes for Fluent meshing based on the code existing in that file or the project. And once we like what we see, we could choose to add on top of it to increase the functionality. Next, let's look at some HTML export of Fluent meshes that have been generated. Again, we can start off by writing a base class and add functionality to it. What's special here is we could also instantiate that class and create some export options based on the methods created by GitHub Copilot inside that class. We could also comment out existing code snippets which were giving context, as well as create some export options and dimensions. Once we run this code, Ansys Fluent kicks off and generates the HTML file we requested, which can then be easily integrated into any Python web apps. The last use case, we'll focus on extending some web apps' existing functionalities. Here is an electromagnetic case of web app of an electric motor where we solve the electromagnetic problem as well as the thermal problem. In electromagnetics, we could look at the core losses, However, we could also specify the simulation parameters for thermal simulation and launch it. Here we are basically looking at the thermal results, the min, max, and average of all bodies. Now we would ideally want to look at each individual body inside that motor. So here is where GitHub Copilot will work its magic, where we could extend the all bodies piece of code to, let's say, the rotor, for example, specify the temperatures, the min, max, and the average. And once we like what we see, we could then use the code completion and auto generate the code for all the bodies inside the motor. As you can see, results are auto tabulated or auto extracted, and we could choose to add some more details as we see fit or correct anything we don't like. Here you could see the results generated for all the bodies that we desired to see. That was the last demo I had. Thank you all for your attention.
Thank you so much, Sandeep, for showing us the power of PyAnsys with Microsoft technologies. If you are interested in joining our developer community, let me guide you. As a developer, you can navigate to our new Ansys developer portal at developer.ansys.com. This hub provides access to technical documentation, training materials, expert forum, and links to our developer tools and libraries available on GitHub/PyAnsys. All our content is free and open. Now, if you're building a new application that is using PyAnsys and want to discuss partnerships opportunities for go-to-market initiatives, the Ansys Developer Partner Program is here for you. We will work on licensing, marketing, business and technical guidance for a successful developer journey with your application. We're really looking forward to growing our developer ecosystem with new innovative partners. So again, if you develop applications for healthcare, AI/ML, 3D meshes, and want to integrate with PyAnsys for physics-based simulation, we really want to hear from you. So how can you contact us? Check out developer.ansys.com/partnerships. Provide us your contact information on the form, and we will be in touch with you shortly. Thank you.
Thank you very much, Sandeep and Olivier. We're now going to turn to the next project. Tyson Reed is the product manager for Ansys Discovery. Tyson is going to walk us through how his teams have helped integrate Microsoft 365 functionality with Ansys Discovery, which opens up tremendous value for Discovery users, as well as very interesting collaboration capabilities. Take it away, Tyson.
Thank you, Andy. Hi, my name is Tyson Reed, and I'm a product manager on Ansys Discovery. Today, I have the pleasure of showcasing the Microsoft 365 integration for simulation. I will be showcasing this partnership using Ansys Discovery. So as a quick overview, Ansys Discovery is the start point for all simulation. Engineers begin simulating using Discovery early on in the design process, where they can then rapidly explore design variations and multi-physics use cases, while taking advantage of Discovery's innovative user experience. And when they're all finished, they can easily send their results to our flagship products for deeper analysis. The demo I'll show at the end will be using Ansys Discovery to perform simulations on this wireless router. Now, our partnership with Microsoft has brought enhanced collaboration to simulation workflows. Logging in with their Microsoft 365 credentials, engineers can use OneDrive, SharePoint, or Teams for file management. Colleagues can also easily collaborate on designs using the built-in commenting on the Discovery desktop app or our companion web application. This integration allows product design teams today to work more effectively together than ever before, with all of their tools connected seamlessly throughout the enterprise. And now we'll show you a quick demo of the Microsoft 365 integration with Discovery.
Christine is a design engineer who regularly uses Ansys Discovery for simulation. Leveraging Microsoft capabilities, she is able to easily collaborate with her team to gain critical insights into a new design. Anyone on her team is able to pick up where she left off by collaborating in a web app or by making in-app comments. Simulation results are available to the rest of the group on Teams. After producing thousands of design variations and finalizing her digital prototyping in Ansys Discovery, Christine can quickly save her project to Teams, OneDrive, or SharePoint.
Well, that's it for our talk. I really want to thank everybody for attending and for watching, and I hope you learned something interesting. If you'd like to contact us, there's many ways to do it, www.ansys.com. There's a tremendous amount of content here on our build page as well, so please reach out. I want to thank our presenters, and I want to thank our great partner, Microsoft, for hosting this event and having us attend. For those of us attending Build in person in Seattle this year, we look forward to seeing you. We'll be on the 3rd floor. And for those of you attending virtually, we hope you get a lot out of it as well. Thank you very much.